So, as mentioned earlier, this Friday is the end of marking period 2. So due this Friday, our Starfield, and the encapsulation worksheet, and the mixed coding practice, these two things over here are newly posted. The encapsulation worksheet is kind of short, and after today's lecture, you should be able to fill out that. Coding bat mixed practice, this is not just arrays, it has some stuff from before too. Mr. Simon and I are having fun with these coding problem sets as we create them, so here you go. Just like previous weeks, a little bit more complicated since it uses all the ideas we've used so far, minus objects, since you can't really do objects in coding bat. So all these things are due Friday. You do have a little bit of wiggle room if you need an extension. Likely you can go into the weekend for me, but do prioritize in getting it done soon. Questions or comments about these things? Your reflections are due this Friday. Cutting you some slack with last Friday's reflections. If they're not in yet, make sure you reflect on what happened last week, and I will grade them soon. Okay. So, if you remember from Friday, we looked at some example programs and we did some counting with member variables, member methods, and local variables. That skill is really important for this next part, right? When you look at this thing, just two kinds of members of the class. So in total, if we just say how many members does this class have, that includes member variables and member methods, what's the answer? I hope you're thinking 5. There are 2 member variables and 3 member functions. Some method, some other method, and the constructor, so that makes 3. So here's the new idea. Part 1 of encapsulation is class members can be labeled public or private or neither. Public and private, you're familiar with those words. Like a public library, everyone can go there. Things that are private, only a few people know, or it's exclusive to you. So notice the color coding here in this example class called bogus. There is the red word private, int x, public, void set x, and then in here you have int some local variable, okay? So local variables are never public or private because local variables are not member classes, or class members. So that's either a variable or a function. That's the new stuff. We'll see a little bit on why it matters. So private means only available to other class members within your class. So as seen here, private int x and nx equals some num that's passed into this method here. Actually, I've taken back to last week. I forgot I skipped over getters and setters, so maybe we'll take a look back at that slide. Sorry. So take a pause with public and private. Right now, you just know them as new labels. We go back. So access, like getters and setters, these seem kind of redundant, but you need them when we talk about encapsulation. So here, you have get foo. Its single job is to look at the member variable nfoo and return it, just like you do in a coding bat problem. It reports it back to whoever called this function, get foo, as a part of the foo class. So we call this an accessor. With formal vocabulary, you'll often hear this kind of function here called a getter, because it returns a member variable, and you know what a member variable is from last week's practice. The return type should match the type of the member variable. So these things are useful, right? We introduced this accessor because when we have public and private, you need to access like private information through like the accessor method or the get method. It's like going to a person and it's like, hey, how old are you? And then you have to respond to that question in saying like, oh, I'm blank years old, versus like someone just stalking you online and finding that information. Well, then thus you've made that information public somehow. It is no longer really private to you if you post it on some kind of social media. Hope that analogy makes sense. Okay, so we're back here. So notice this example, we use the private keyword. We've made this member variable nx private, and such a move is legal. We can still modify it within this setX method. But notice down here, like later in the code, we can no longer do something like this, bob.nx equals 5, or whatever, die.myx equals like 10. This causes an error now because we've introduced this private keyword. Yeah, so far so good. See how such a use is now restricted due to the private keyword? Cool. So the public kind of behavior you are used to. So notice this method right here, setX, we've made it private. Sorry, we've made this setX function public. So anyone can ask the bogus class to change its x coordinate, which is what this line of code does. So here, notice bob.setX equals 5. This is okay. So like before, let's try to provide a little bit more context on why that is. So you are a part of a larger software team. You're working on Splatmaster 4, a paintball computer game. And your specific job within the team is to write a blob class, very much like the particle class, that represents the data and behavior of the paint blob. And all the other programmers will use your class in their game. You bear the responsibility. So we first make a class that looks like this. Pretty standard. Should look like a particle in how it moves from the center outwards. So later, we find this problem. The blobs aren't moving. And so you think d speed is super small, x and y may not change when it gets casted, like here. A slight bug, because there's a rounding error. When you round 0.3 with an int, it gets 0, so x is updated by nothing, so then it doesn't move. Then you take a guess, you need to change your x and y's, which were originally ints here, to doubles. And to you at the moment, you think, okay, there's not much change. It only affected me. But remember, now that you're on this big software team, other people are using your program. They're building off of your code. And suddenly, on the other side, right, for your teammates, they're using lines like this, and suddenly they get this error. Int line float 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 is not applicable, right? We're seeing int int double double. What does this mean? Looks like this part here is causing the error. There's a bunch of things going on because it's specific to processing, and in that it expects floats, but we're giving it 2 ints and a double. But anyways, your team is now super mad at you. Your mistake means they have to go back into their code and cast the x coordinate by doing this, and then changing all the other data types, because you made it into a double to resolve the errors on your end, right? So they complain to your boss, and wouldn't it be nice if you made changes to your code so that anyone that uses it no longer sees your changes and just kind of accepts that it will work. So if you could make changes to your class without affecting client programmers who use it. So this is the idea of encapsulation, using these public and private keywords. So when you use private, you hide data members. And so what encapsulating is putting things into smaller bits. I forget the actual English definition. Perhaps we'll look that up. I only think about it in the programming sense. The action of enclosing something, or as if in a capsule, a succinct expression of deception of an essential features of something. Okay, hiding. So here's what you should have done when working on a larger team and you're writing a class that is used by everyone else. The member variables, they're all private. So only you as the programmer of the blob class can modify these set of variables. And if someone on your team wants to change like the x coordinate, for example, they would have to use these things. Down here, you recognize this accessor method, the getter, so that they can view the data in myx. And if they wanted to change it, they would have to go through this method, setX, which updates the x coordinate. So now, with whatever your team uses, their lines of code will look like this. They have to get x, right? They have a blob defined, and now they have to use the accessor method to get the x and y coordinates. And for you, changing the data types here doesn't require a change on their end. Their code now still works the same, even though you've changed something within the class. They're using these accessors and getters and setters instead. So there is somewhat of an, oh, is this an inconsistency? Yeah, no. This is okay. If you change this to a double and get x still expects an integer, then you would still have to do this cast here. So to help you organize these, because how do you know later on that your variable is in fact private? And one naming convention a lot of programmers use is with private variables, you'll append my or an underscore out in front. So here, private int my x, my y, my speed, my angle, my color. All those things are private, and later on when you use it, you kind of have a hint on why it's private because you have the my keyword in front. So we go back to this idea of getters and setters. If you're using public and private, you need the help of getters and setters in order to abide by the rules of those encapsulation, this like permission issue. So the fancy name for this is setters change values, so they're called mutators. Getters are accessors because they need to access said information. You may see these two words on the AP test. You'll often hear me say getters and setters instead because it's easier to say. So as seen before, these are the examples of them. setX updates myX with whatever the user tells you as in an input argument. myX just returns it, shows it back to the user. Notice there's no return here because it just involves the equal sign. Update, assign x to myX. And these methods are usually public. Do we need protected? So I don't know if this keyword is on the AP test. So protected is very much like private, but when you inherit things, when you use the extends keyword, then these variables are given, like the subclasses or the ones that inherited from it, the children can access the private information or the protected information. Do I have? So these things, you're like, okay, Mr. Chan, like, why do we need public and private in the first case? Right now, it seems super extra. Many courses in object-oriented programming would kind of lump this later in the course called, and under the topic of advanced object-oriented programming. Like right now, you don't really need it to get things functioning. However, like later on, when you build bigger and more extensive programs, as seen in that example where you're writing the Splat Blaster 4 paintball game, public and private do help you out because it prevents you from shooting yourself in the foot later. So by hiding or abstracting variables and making them private, there's kind of a level of trust to whoever wrote the class that's like, okay, it's working. I'm giving you these accessors and getters, and along with any other public methods, please use those, and anything else that happens, assume that it works, so that you have less stuff to worry about. So encapsulation, in that regards, has some style to it. It's like, okay, why do you indent things and use the squiggly braces as it is, so that it's more readable? Encapsulation helps you organize along those same lines. Keeps you organized, keeps data you want to keep to yourself private. Anything else that wants to modify it, you're going to make those methods public. And I can verify, yes, it is in fact used in the professional world. Like when you're looking at code bases that are like 1,000,000 lines of code long, not everyone is going to know what each of those 1,000,000 lines do. Instead, you just know like a subset of those, and then you got to assume, okay, whoever wrote that, it works. So then I understand like this chunk of it. So I think I have 2 more slides. Yeah, so a couple more slides and then we'll be done for today. So here we have an example class. Inside of it has nnum. This thing, when we're writing it now, from this point onwards, it should be private because it's a member variable. And then when we make a member variable, we need to create these accessors and getters. Because it's private, we need to, if anyone wants to use mynum or see what nnum is, it needs to go through getNum and setNum. And these accessors and getters, these getters and setters should be public, so anyone can use them, now that you made mynum private. But that requires some kind of foresight in saying that, okay, if someone needs to, like, does someone actually need to use it, like my x and y coordinate, yes, then you would have to create these methods. It's strange right now too, because you are the only programmer, so that use case, that reason on like why we use public and private are somewhat redundant, other than me and Mr. Simon are grading you on using public and private because it's on the AP test. So it's kind of like a conflicting message right there. So if you decide to change the data type, then remember the user still expects an integer, so you have to use some kind of casting. But again, in order to know that, you still require that level of foresight on like, oh, someone is using this as an int. I need to keep it that way. So with the next couple of assignments, asteroids is what you're working on for the rest of the semester. You need to be using encapsulation, also known as data hiding. So you should have all members being member variables or member functions be public or private. Later on, we talk about protected. So just as a rule of thumb, from this point onwards, Your member variables should be private. Your member methods or member functions should be public. Private variables may need get and set methods. You could write them all at the beginning, but then that causes your code to be really long. So sometimes you need getters and setters for those that need access to them. And then local variables that we mentioned, that we identified last week, they are never public or private because they're temporary. They don't require such a label. All right, so that's today's lecture. In retrospect, I don't think I did a good job in explaining it. So do ask me questions throughout this week about encapsulation. It's hard for me and Mr. Simon to really come up with examples of it. You'll see it in your you see it in Starfield, and then next up we are gonna make the spaceship, and we're gonna use encapsulation. That'll be after this marking period ends. For now, focus on Starfields. Focus on the extends keyword. Think about well, you don't really need to think about public and private yet, but do the worksheet and practice that a bit. So that's class. See you later. Bye-bye. See you later. Bye, Alan. Bye, Michelle. Bye, Lane.